I have this web application that's external facing, collecting and storing consumer personal identifiable information in JSON format. And while at rest, the data is stored unencrypted in plain text, putting us at a high risk of our consumer information from being exposed. To mitigate this risk, we need to be able to encrypt or tokenize specific fields that are tagged as PII based on our internal company policy. However, in this scenario, we don't have access to the underlying operating system or database to enable or apply encryption. Nor are we allowed to make any code changes to the application because of how mission critical it is to our organization. So, what can we do to protect our data? This is where Thales' newest CipherTrust Data Protection Gateway solution comes in. CipherTrust Data Protection Gateway, or DPG, enables DevOps and DevSecOps teams to transparently protect sensitive data using REST APIs by the web application without making any code changes. It sits inline between the client and the application. It is a containerized solution that is fully compatible with Kubernetes orchestration systems such as Helm, Ansible, and Terraform, making it easy to deploy and scale. The solution also works in conjunction with our FIPS 140-2 compliant CipherTrust Manager, giving us a centralized key management, policy-based access controls, and detailed audit logs across multiple applications. As a developer, I no longer have to think about which algorithm, operation mode, IV, and more importantly, how I'm going to generate, store, and back up my encryption key. And as a security engineer, I'm able to enforce separation of duties between the key administrator and the key consumer, which also helps me mitigate the risk by limiting and controlling access to the data. Let's take a look and see how it works. Over on my CipherTrust Manager appliance, I start by creating a new NEE interface just for my data protection gateway deployments. That way, I can keep it separate from my other applications that are using NEE for key management and also help me troubleshoot any issues that might come up by narrowing down or pinpoint the problem to a specific port or interface. Next, I'll create an AES-256 encryption key that is exportable, and then start by adding a new application under the Application Data Protection Product section of the UI. We'll give it a name, select DPG for the connector type, and specify a few settings to tell the connector how to connect, how to secure, how to authenticate, how to log, how to persist the connection, and how to cache the encryption key. I'll skip adding a policy for now, confirm everything looks good, and once I save the changes, the CipherTrust Manager will generate a new registration token that I can now use to deploy and run my data protection gateway, building a trust relationship between the container and the appliance. At this point, the CipherTrust Data Protection Gateway container is simply bridging traffic between the client and the application without any interruptions. The next step is to start protecting the PII data that the application is collecting, storing, and processing. I'll start by creating two new protection policies, one focused on matching against alphanumeric characters, and another focused on all digits. We'll give each one a name, specify the algorithm, the encryption key that I created earlier, and a tweak plus an algorithm for the tweak to do some sort of format preserving encryption with the data. Once that is done, I can go back to where I added an application earlier, and under the policy tab for that application, I'm now going to add two new endpoints. The first one will be used to protect the data as it is sent from the client to the application. I'll start by specifying the URL of the path after /API along with the HTTP method of the request. Next, I'll add 3 tokens to encrypt 3 different fields based on what I've identified as PII under the request token section. Keep in mind that the names I give the tokens needs to match the names of the fields that I want to protect. Looking at the JSON payload request, I create a token for the email address, the credit card number, and the social security number. The second endpoint I add is going to be used to control which fields get revealed when a client accesses their own record. For this endpoint, the API URL is going to be /getConsumer, and the method is going to be get. And for the tokens, I'm only going to create one token on the response token section to only reveal the email address and not the credit card number or the social security number to show how we can control access to the data. Now, when someone completes and submits the form, the CipherTrust Data Protection Gateway container is able to intercept the request, look at the URL, and see if it finds a match based on the endpoints we defined earlier. If it does, it will proceed to encrypt the fields based on the tokens we created earlier and continue to forward the request to the application and ultimately make its way all the way to the database. Because we are encrypting the data before it hits the application or database, we're able to mitigate and reduce the risk to our critical data from being exposed from an insider or an external threat. And if someone tries to access their own record, the CipherTrust Data Protection Gateway container is able to decrypt and only reveal the email address based on the response tokens we configured earlier. Wow. Without making any code changes to my application, I was able to deploy a container between the client and the application, make a few configuration changes here and there for how I wanted to protect and control access to the data, enforce separation of duties between the key administrator and the key user, eliminate the human error of the developer getting the encryption and key management wrong, and if I need to make any changes, I can easily do it from the UI, making the solution very user-friendly and agile. If you'd like to see how you can start protecting your sensitive data inside a REST API web application that is using JSON as a data format structure, visit the URL shown here on the screen to learn more about Thales' newest CipherTrust Data Protection Gateway solution and how to get started. Thank you for watching.